Hi guys, today we will be looking at ionic bonding. Okay, so let's first see what is an ion. An ion, let me write it down. Okay, so an ion is nothing but charged particles. Charged particles, right? They could either be single atoms like aluminium, okay, or they could be as a group of atoms, for example, carbonate, right? So, basically, if you look at what an ion is, it is the net charge of a particle, okay? The net charge. So, let's dive into what that is. But first, we need to look at the electronic configuration or energy levels of the atom. Okay, let's take the aluminum element, okay? First, we need to see its atomic number. How many electrons are there and how many protons. But for now, let's see the electrons. We got 13 electrons over here. Now, as you know, the energy shell rule for these types of metals is a 2, 8, 8, then it goes to 16, then 32, and so on, right? So, 13. The first shell gets full with 2. Then the second shell is also full, and the third shell, there's only 3. Okay? So this is the electronic configuration for aluminum. So, yes. Let me just... Okay, cool. Okay, so on the first shell, you got 2. Okay? Second shell, you got 8. 1, 2, 3, 4, 5, 6, 7, 8. And the last shell, you got 3. Okay? And, okay, 1, 2, 3. Okay? This is how it looks. I know, it's a very bad diagram. Let's clear this. How can I clear it now? I don't know. So basically just, okay, is there a eraser? No, there's not a eraser. Okay. Basically, it's this whole circle. First shell, but it's occupied. This shell, there's 8. This shell, we got 3. Okay? So, is this particle stable? It is not. Because in order for it to be stable, the third shell must have 8. Basically, the shells must be full. Okay? You introduce a fourth shell, again you need 16 new electrons. Okay? So, basically, for it to be fully stable, we need it to match 288. Okay, the third shell must have 8. We are off by 5. So, in order to make it 5, we could either get rid of 3 electrons, or we could just add 5 electrons. Okay? So that means aluminum becomes, aluminum's not A, it's Al, right? Aluminum becomes Al, and let's get this guy here, and aluminum becomes aluminum and minus 3, but no. So one more thing to add. Electrons, if you look at the charge of an electron, it's negative. An electron holds a negative charge. 1 second, there's an ad. Okay, cool. So an electron has a negative charge. So by adding 5 electrons, you're getting 5 negative charges, meaning that the overall charge goes down. So if you want the plus 5, it becomes minus 5 because you're losing 5 charge. Okay? And again, if you want to take away 3 negative electrons, it becomes Al plus 3. Now, people usually don't write minus 5 like that, they write 5 minus. It's weird, but they just write it like that, okay? Okay, so, yeah. 5 minus ion. So that's the ion theory. That's how you judge if it's an ion. And another thing, we could look at the periodic table. Okay, let me get the periodic table right up. Periodic table, here we go. Okay, periodic table. So, as you can see here, we could just memorize it. So group 1, there's always going to be just one extra a positive ion. Basically, for example, Li plus 1. Okay, beryllium, all these guys are going to be a plus 2. Now, we're going to skip all these guys, and straight away to boron, we get a plus 3, plus or minus 4. Now this guy, because you know there are 4 extra guys in the shell, you could either add 4 or minus 4. So it's plus minus 4, then we get 3, 2, 1. Okay, and these guys are good. So they are just, they don't have any they're not unbalanced. So the outer shells are always full, meaning that it's 0. You don't need anything here, right? Yes, so that's that. Okay, let's see electronic in groups, right? Okay, cool. Alright, next one. Okay, so let's see what happens when we add 2 guys together. Let's take ammonium, right? Ammonium, yeah, like that, right? Ammonium is NH and a sub 3, not sub, but wait, NH4, 4, and it's a plus 1. Okay, 1. No, I don't want you. Okay, good. Like that. Okay, so let's break it down. We got our nitrogen, right? Nitrogen. Let's see what nitrogen is. Okay, so nitrogen, I've got a periodic table here. Nitrogen's atomic number is 7. That means it's 2 dot, not 8, 2, 5. Okay, so what do we need to make this balanced? 5 plus 3 is 8. We need to add 3. Okay, so this guy becomes nitrogen. Okay, so basically to add it you need to, yeah, nitrogen M minus 3 minus. Okay, basically it's in that group. Okay, here 3 minus, because you know we need to add 3 negative charges, so you need to basically add 3 negative guys. Okay, now we look at hydrogen. Hydrogen, what's the atomic number on that? 1. Okay, cool. So literally it's just 1, but you need 2, so basically you need to add another electron. So hydrogen is in the minus 1, in the plus 1 group, right? So it's H1, right? 1 plus. Okay, you know. Okay, yeah. Okay, so hydrogen's in this group. Okay, so now if we get NH3, let's copy that so we can leave it. Okay, NH3. Okay, cool. NH3. Okay, so we got a minus 3 and a plus 1. How are we gonna balance this? So we can't just leave it like this. This guy we can make it. God, that arrow's awfully small, isn't it? Anyway, so this guy, we got a minus 3. We got a 1. So how many of these guys do we need to get this? Okay, so yeah, if we want nitrogen and hydrogen purely, as you can see, we got a hole with 3 blocks. We got 1 block. We need 3 blocks to fill it, to balance it. So we got N and H. We got a NH. Oh my days, where is that? Okay, we got a NH, and we need yes, it becomes NH3 because we need 3 blocks. Okay, but they wanted this, so basically assume we make this 4, right? What happens? We got an extra 1 here, so the overall charge, the overall ion, is going to be a 1 plus, because we got an extra hydrogen, an extra electron. No, we don't have an extra electron, right? Yeah, hydrogen's the electron eater here, right? This guy's the electron donor. Okay, so we got a +1. That's how it matches, okay? Yeah, so it's quite unstructured, the course, but yeah, hopefully it would help. So again, these could be drawn in dot and cross diagrams, right? For example, let me go for one more example. We're going to run out of a page here. Okay, good, new page. Fresh start. Okay, cool. So assume we get sodium chloride, Na and Cl, right? NaCl. If we look at sodium, Na, Na's guy is, it's in the first group, periodic table. So, plain. Anyway, so Na's in the first group, so that means it has a +1 charge, right? Chloride is in the 7th group, so that means, using the periodic table, I mean you can do the math and just see, but anyway, it's in like that, okay? So we've got NaCl, I'm gonna go 1 plus space 1 minus, okay, move it, I don't want, okay, so we get now Cl, and we get Na, like that, right? So if we look, basically, this guy in his diagram, so let me load up the graph real quick, can't take too long. Okay, sodium dot cross diagram. Okay, cool, we can see that. Cool, we got a sodium dot and cross diagram. Okay. Okay. Oh, already got sodium chloride. Okay, anyway, sodium. Okay, Na, sodium. Is that sodium? Yes, so this is sodium, this is our chloride. As you can see, this guy, on his outer shell, he has one extra. One electron extra, right? That's what we saw was the 1 plus, okay? He's got one extra electron. Basically, you add a negative charge and get rid of this guy. This guy has, how many? 2, 4, 6, 7. He has 7 on his outer shell. He just needs one more. So how these guys would bond, this guy would donate an electron there, and they bond like that. Yeah, they just bond, okay? Yes, it shows here. This electron goes here and creates a pair, and then they bond, okay? Like this, yeah, perfect. They bond, and this is the, I know, there's more science behind it, but they bond. This is how they share an electron, and that's how the bond gets created, okay? Yeah. Okay, so this is again dots and cross diagram. It comes up in exams anyway. So yeah. Hope this helps. Quite a rushed video, but regardless, hope it helped. And yeah.